All right, I'm going to try to get swerve working here using YAGSL. I'm on the yet another generic swerve library document. So there's a lot of information on this. They start by describing what swerve is. They talk about swerve drive here under fundamentals and what swerve modules, how they work. And then they kind of go into bringing up swerve. This is really where you kind of want to start working if you already understand what swerve is for the most part. They preface it by saying it takes time and there's just going to be some work here. That's fine. They talk about swerve information, how you're going to measure different things on the robot. We'll probably just pull some values from what I have in my program right now because I don't have a robot next to me. But essentially, it's just telling me you got to be careful when you measure these things. We talk about checking your gyroscope and calibrating it. The Pigeon 2 does a pretty good job, but if we ever notice that off, we can go in and calibrate it. Checking your motors, you kind of want to be aware of when we say front left, front right, rear right, back right, back left, what we mean. There's also an important thing here. You can see that they say that the bevel gear sides must face left. So when you are talking about things pointing forward and you don't know which way to orient the wheels, you always need to make sure the bevel gears are on the left side. Front is forward, it's positive X direction. To the left is a positive Y. And that might seem strange compared to your algebra class, but that's just the way the gyroscope works. So then you're going to go in, you're going to create a configuration file. They've got a lot of these sort of diagrams so you can know what's being talked about, other things like that. But really, you can come down here to the very bottom and you can just click input the data you find in the configuration web page. I'm going to go ahead and click this right here. It's going to take me to create a configuration file. I'm going to go through and set these based off of our off-season bot. So the IMU is a Pigeon, actually a Pigeon 2. Let's select that. The IMU ID, this is the CAN ID for your Pigeon. Let me check and see what it is in ours. Let's go in here. Let's say here. Where did I have this? Physical properties, maybe? No. PID properties. Controller properties. No. Swerve drive. Here we go. Oh, it's CAN ID 0. That makes sense because you wouldn't have more than one Pigeon. So the PID is 0, and it's CAN bus. I'm not going to give it a special name. You'd put a special name there if it was on like a carnivore or something. Now let's look at the modules. What voltage will they be running at? It's a 12-volt battery. Often it runs at like 12.5 or a little bit more, but we're going to do volt drive control. This means that it's more consistent if we ever drop from 12.5 to 12.3. We're not saying go 100%. We're saying go at 12 volts, so we can figure that out. I wouldn't mess with any of the grip coefficient. The current limits, the default ones are good. Here's where we kind of start getting into our specific to our modules. So what's the angle steering azimuth gear ratio? I can look that up in what I have here. I can say it looks like it's the angle gear ratio is 21.4. Now, where did I get that? Let's go here to Swerve Drive Specialties. Here's the MK4i. And if you scroll down, it'll tell you the ratios. The steering gear ratio of the MK4i is 150 divided by 7 to 1. So if we do the math, 150 divided by 7 is 21.4285. And you can see that's what I've got over here. So I got that directly off of the manufacturer's webpage. So 20, what did I say it was? Just copy it. Copy that. Put it right there. There we go. Angle steering azimuth conversion factor. You don't need to worry about any of that. I don't believe. Let me double check. Yep, no conversion factor there. The wheel diameter in inches. These are 4-inch wheels. You can once again find that on the SDS page. They'll talk about the wheel size, 4-inch wheels. The drive gear ratio. We're running L2s on our off-season robot. So let's go down here, find L2. The L2 ratio is 6.75 to 1. Let me double check that's what I put here. Yep, that's what I have there. So these are all things that depend on the module you're using. 6.75. No conversion factor needed. Ramp rate for drive at 0.25. Ramp rate for angle 0.25. I'm not going to change those. Those are probably decent defaults. Front left module. So how far in the X direction, how far in the Y direction is the front left module? Remember, X forward towards the front of the robot is positive. I don't have the robot in front of me, so I'm just going to cheat here. Front left location is 8.125 forward. And the location Y is 9.125 to the left. Now, where did we get these? We actually got out a tape measure and measured the center-to-center distance of those wheels, and then divided it by 2. So those front wheels, the left and right side must have been 18.25 inches apart, 18.25. Divide that by 2, you get 9.125. And then the front to back distance between the wheels must have been like 16.25. Divide that by 2, you get 8.125. Now, the absolute encoder offset, I know what that is on our off-season bot, but realistically, you wouldn't know that yet. We're going to bring up the code, and then we will modify that value. Once we have code running, we'll be able to orient the wheels directly forward, be able to read the encoder value, say, well, that's the offset, put that offset into our file. The drive motor type is a Spark Max. We're using Spark Maxes. Our drive motor ID, I'm going to assume we're going to have 1 and 2 in the front left. So drive motor is CAN ID 1. I don't know yet if it's inverted or not, so I'll just leave that. The angle motor is also a Spark Max, and we're going to say its CAN ID would be 2. And we don't yet know if it's inverted or not. Those are things we would kind of learn as we bring up our swerve modules and sort of see how they behave. Absolute encoder type, we're going to select the thrifty encoder. That's what we're using. Absolute encoder ID. So because these thrifty encoders are analog encoders, they'll plug into analog slots on the Rio. This is the slot that's plugged into on the Rio. So I'm going to leave it at 0. And it's not on a CAN bus, it's a thrifty. All right, front right motor. So this should be similar to front left. It should be 8.125 forward, but the opposite direction in Y. So let's go 8.125 forward, and in Y it would be negative 9.125. Double check those numbers. Yep, looks good. Everything else is pretty much going to be the same. Absolute encoder offset, we don't yet know. It is a Spark Max. Oh, the drive motor ID, we're going to go 3 and 4 for the front right. So we got another Spark Max, and it is 4. I don't yet know if there's any inversions. We're using the thrifty encoder. And this one would go into analog port 1. All right, let's keep going. Back left. Forward and backwards is now going to be negative 8.125. And in the Y direction, it's going to be the 9.125 because this is the left. Remember, left is positive based on the diagrams on YAGSL's documents. Absolute encoder offset, we don't yet know. We're once again using a Spark Max. We used 3 and 4 on that one, so let's do 5 and 6 back here. Another Spark Max, 6. And another thrifty encoder. This one will be, we have 0 and 1, so this would be 2. And then back right, it's going to be negative 8.125, and to the right is negative, so negative 9.125. This is back right motor. Absolute encoder offset, don't know. It's a Spark Max. We've used 3, 4, 1, 2, 3, 4, 5, 6, so this is 7. And drive motor invert, no, Spark Max, 8. I don't know if these are like CAN IDs. I'm just kind of going in order here, but we need to check them on the Rev client and change them as appropriate. Absolute encoder type is thrifty. This will be slot 3. We have 0, 1, 2, and 3 for our absolute encoders. Everything looks good. Heading tuning, joystick radio. This is for a special type of driving. I'll leave these as default. Okay. Module tuning. I'm going to leave these also as default. This is stuff that we'd have to kind of test around with sysid or just, on the fly to see how this looks. But we're not going to mess with that right now. That would kind of be some next level stuff. I'm going to click download, and it'll download a config file. Let me go ahead and open that up, see what it looks like. It says Swerve. I've got my modules, my controller properties. All these config files are good. Let me go back here. It's under my downloads. I am going to go ahead and drag this onto my desktop for later. Okay, I've got my config file. I think that's a good first step. I'm going to end the video here. I'm going to pick it up in a moment. So